So energy of the particle in simple harmonic motion, it has a kinetic and potential energy both. So as you know, as it oscillates, at the extreme position the speed is 0. So if you draw the graph of kinetic energy here, so at the ends it will be 0, at the two extremes it will be 0, and at the mean position it is maximum. So it is like this. And if you analyze the nature of the graph, so in a half, so V equal to omega root over of a square minus x square. Therefore kinetic energy equal to half m omega square into a square minus x square. So you see the nature of the variation is parabolic. So now if you look at the potential energy curve, so where do you choose zero potential energy? So that's your choice. Wherever you choose zero potential energy, that is the reference. But at the mean position, potential energy is minimum because kinetic energy is maximum. So the curve will be like this. Minimum at the mean position and maximum at the extreme positions. Now if we choose, if the reference of potential energy is the mean position, then the expression for potential energy will be half kx square. See the k, because the force in SHM is like the spring force, and for the spring we know potential energy is equal to half kx square. So here we will replace half m omega square x square. So that is potential energy if the mean position is taken as the reference. Okay. So next page we will discuss about combination of simple harmonic motions in same direction, that is combination of two SHM. First we will start with combining two SHMs in the x axis. In same direction, that is both simple harmonic motions will be along the x axis, and we have to find the combined simple harmonic motion. That is the equation of the combined simple harmonic motion. Now what is combining SHMs? Combining SHMs is actually combining the forces causing the SHMs. So basically if they have the same, if this is a particle, say here, and it is acted upon by two forces, say F1 and F2, two forces causing. See, if only F1 would have acted, that due to F1 only, equation of SHM would be x1 equal to a1 sin omega t. Suppose this is the equation of SHM due to force F1. Now due to F2 only, equation of SHM would be x2 equal to a2 sin omega t. Say suppose there is a phase difference of phi, this may lead by a phase phi. Now what is the combined equation? So by intuition you know, okay, combined SHM, obviously the combined SHM, combined or the resultant motion, we can get by this equation, x equal to x1 plus x2, by adding the two displacements. So This is known as the principle of superposition. Yes, that is true. By summing up this x1 and x2, you will get the final x. But why? So this is the principle of superposition, that's okay. But why do you take it for granted? Now, if you look into the root cause of it, the forces causing SHMs is, say, m, mass of the particle, into double derivative, or that is m, this for SHM1, I mean that for the force F1, due to the force F1. So here we will get, but due to force F1. Let's put vector sign on this. In general, let us put vector sign on this. Now, for the force F2 or due to force F2, this will be the equation x2 vector sign double dot equal to or d2x2 F2, right. Now, when both the forces act simultaneously, both forces F1 and F2 act, then net force will be how much? F1 or F equal to F1 plus F2. Now, therefore, from these two differential equations if you add, so it is m d2. Now, we can add this x1 plus x2. This is equal to F1 plus F2. So, from this we know that the resultant equation of the simple harmonic motion is given by, as these are in the same directions, we will just neglect the vector sign and just put here x equal to x1 plus x2. So, now this is possible because the differential equation governing the simple harmonic motion is linear differential equation in nature. That is why the principle of superposition works. Principle of superposition means x equal to x1 plus x2, and linear differential equation means, see, you have power on x as 1. If it were dependent on the second power or third power, say if the relation of force would have been this, F1 is dependent on derivative or second derivative of the nth power of x, then this type of superposition principle would not have been possible. So, now we will see how the two SHMs combine. Here, suppose combine the SHMs along x axis, two SHMs. So, individually they are like this, A1 sin omega t and x2 is A2 sin of omega t plus phi. Now, resulting SHM, you know, now we are convinced that x equal to x1 plus x2. Therefore, x equal to, just to expand the terms, sin omega t plus A2 sin omega t cos phi plus A2 cos omega t sin phi. Now, A1 plus A2 cos phi, here sin of omega t plus A2 sin phi cosine of omega t. Now, this expression can be simplified in the following way: this A1 plus A2 cos phi whole square plus A2 sin phi whole square multiplied by a1 plus a2 cos phi divided by square root of, again so it is this thing, no? So I will just put it like a dot 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 multiplied by sine omega t plus a2 sine phi divided by square root of, I mean this whole thing will come here, t into cos omega t. Okay. So as you know that this term, this whole term can be written as cos alpha, and this term can be written as sin alpha. Why? If you square and add these two terms, you get 1. So here again, if you simplify this, it comes out to be a1 square plus a2 square plus twice a1 a2 cos phi multiplied by sine omega t plus alpha. So this is the resultant SHM. So the resulting amplitude A suffix r for resultant is given as this, root over of a1 square plus a2 square plus 2 a1 a2 cos phi, where phi is the phase difference between the SHMs. Now, so there is a shorter way to remember this formula, that is, the expression reminds us of vector addition. So the SHMs 1 and 2 have a phase difference phi between them. So now this is for SHM 1 amplitude A1, and at phase difference phi from phi with SHM 1 there is SHM 2. So there comes phi and this is A2, and there it goes, this is the resultant amplitude AR, and this is the angle alpha. This is an easy way to remember it, but actually amplitudes are not vectors. They add as if, I mean the equation resembles the vector addition law, the triangle law of vector addition. So in this same way we can expand. So suppose you have to add 3 SHMs, I will do it in next page. If you have to add 3 SHMs or 4 SHMs, I will do with 3 SHMs. Suppose superposition of 3 SHMs in same direction. Here also we will consider all SHMs along x axis only. So x1, suppose it happens to be a1 sine omega t, x2 happens to be a2 sine omega t plus, say it happens to be pi by 6. Now x3 happens to be a3 sine omega t plus, say I give it a value pi by 2, right? Any values you can choose randomly and see. So now what will be the equation of the resultant SHMs? So we can expand that vector addition idea. Now here instead of the triangle law, as you know, there will be application of polygon law. Now here I go, a1 for first SHM, and for second SHM the pi by 6 means 30 degree. Okay. So there it goes, a2 at 30 degree or pi by 6, and this a3 goes at pi by 2. There it goes, a3. Now see this 90 degree. Now this is the resulting SHM AR, and this is alpha, So you can write the equation as AR sine of omega t plus alpha, and you can find all these values by applying the polygon law of vector addition, though they are not vectors. Next we will discuss about damped oscillations.